In this lesson, we're going to be talking about how to solve a quadratic equation. In this lesson and the next couple lessons to follow, we'll be talking about different methods on how to solve a quadratic. So today I'm going to be showing you two different methods. Okay, the first thing we need to know is, what do the answers look like whenever you're solving a quadratic equation? Well, there are four different names for the answers to a quadratic equation. And remember, a quadratic is of the form 0 equals ax squared plus bx plus c. That's your standard form of a quadratic. And notice that this is set equal to 0. All of the equations we're going to be looking at are going to be set equal to 0 because we're going to be solving for the answers. So the four different names, the most common name and the one that kind of gives away what it actually means to solve a quadratic is the x-intercepts. The x-intercepts of a quadratic equation are the solutions. So wherever the graph is crossing that x-axis, those are your solutions to the quadratic. Now, another name that you might see is solution. So if you hear someone say, what are the solutions to the quadratic, that just means where are the x-intercepts. Another name for them is root or roots. If you hear someone say, solve for the roots, well, that just means the x-intercepts. And then the last one, which is my favorite, a zero. A zero of a function is where the graph crosses the x-axis. So that's essentially what we're going to be doing as we're solving these quadratics. Now, I do have three images here below of the different types of quadratics that you can encounter. The first one is one that you might see is one that is going to cross the x-intercept twice. And during our graphing section, we actually had a couple examples where you would see an example of a graph or an equation crossing the x-axis twice. Another one is whenever the graph only crosses the x-axis once. This has a special name to it, actually. This is called a double root. I'm going to show you why it's called a double root in just a moment. The last example that you could have is you could have a quadratic that doesn't actually cross the x-axis, and in that case, it has no real solutions. So we're going to be taking a look at this vocabulary as we kind of work along in the section here today. Okay, let's talk about our first technique on how to solve a quadratic. And this is going to be called factoring. So this should be very familiar to you because we've actually already, we've been factoring for quite a while now. So let's look at this first example and solve by factoring. So looking at this, you can see that we have a quadratic and it's set equal to 0. And the first question we want to ask is, do we have a GCF? And because that's always the question we want to ask whenever we're factoring. And the answer here is yes. So let's go ahead and factor it. 0 equals, my GCF is 3x, and I'll be left with x plus 3. Okay, once you've factored out that GCF, ask yourself if there's any more factoring that can be done. And the answer to that is no, this is fully factored. Now I want to introduce to you this property, and you can see the property at the bottom. This is called the zero product property. It says, setting each apparent factor equal to 0 to determine the solutions of the quadratic functions. So let's talk about this idea of an apparent factor. When you're solving a quadratic by factoring, you're going to end up with two factors. These factors are called apparent factors. I just underlined them here in the problem. So we're going to use the zero product property to solve the problem. So I'm going to set each one of these apparent factors equal to 0. So let's go ahead and do the first one. 0 is equal to 3x. It's a very simple one-step equation, but let me go ahead and solve it. So in this case, x is equal to 0. This is going to be one location where this particular graph is going to cross the x-axis. Let's go ahead and do the other one. 0 equals x plus 3. I'm going to go ahead and solve this out by subtracting 3 from both sides, and I'll get x equals negative 3. All right, so these are the two locations in which this particular quadratic function would cross the x-axis, meaning these are the solutions to the quadratic. Now, it's asking us to write our answers in coordinate form. Remember, an x-intercept will always just be a coordinate that starts with the number that you're given, and then your y value would be 0. So I'm going to go ahead and write this. 0, 0 would be my first one, and negative 3, 0 would be my second one. These are the locations in which the graph crosses the x-axis. Okay, let's try another one. In this next one, again, we're trying to solve these by factoring. So my first question should always be, do I have a GCF? And I do not have a GCF in this problem, so I need to go and use another technique. So I see that this problem here is a trinomial, and I see that the trinomial has a coefficient of 1. So I'm going to change my pen color here. Okay, so I have to use my technique on solving trinomials with my a coefficient is 1. So you remember we did this little technique a long time ago where we have a little x, and I'm going to take 1 times 15, which gives me 15, and I'm going to take that negative 8, and I'm looking for two numbers that multiply to give me positive 15, and they add up to give me negative 8. Those two numbers are going to be negative 5 and negative 3. And let's go ahead and factor it. Factor it just like you normally would. I'm going to go ahead and break this down into x minus 5 and x minus 3. And I'm going to set that equal to 0. All right, once I've factored everything, and I can't factor it any further, I'm going to go ahead and set each of my apparent factors equal to 0. Here are my apparent factors. Here's 1, and here's 2. So I'm going to go ahead and take the first one. X minus 5 is equal to 0. Add 5 to both sides. X is equal to positive 5. There's one of my answers. And then my other one, x minus 3 is equal to 0, a simple one-step equation, x is equal to 3. Okay, so here are my solutions to the quadratic. X is equal to 5 and x is equal to 3. So these are the locations in which the graph will cross the x-axis. So to write these in coordinate form, I would write it as such. 5, 0, and 3, 0. And I'm done. And just as a reminder, if you just want to check yourself, you could always take that original function and put it into your graphing calculator into y equals and graph it to see what it looks like and to just ensure that it actually does cross the x-intercept at 5 and 3. Okay, let's try this last one now. Now, this last one, notice that it is not in standard form. It must be in standard form in order to factor it. So let's go ahead and quickly just put this in standard form. I'm going to move my negative 27 over to the left-hand side and set it equal to 0. All right, the first question you ask yourself is, do I have a GCF? And I do. So let's go ahead and pull out that GCF. 3, and I'm left with x squared minus 6x plus 9 is equal to 0. Now, even though we pulled out a GCF, this is not finished being factored. So you'll notice that I have a trinomial in the center here, and that trinomial has a coefficient a is 1. So we're going to go ahead and use that little technique that we used before. I'm looking for two numbers that are going to multiply to give me positive 9, and they're going to add to give me negative 6. Those two numbers will be negative 3 and negative 3. So let's go ahead and fully factor this. 3 is my GCF, x minus 3, x minus 3, and I'm going to set that equal to 0. Okay, now that you're in fully factored form, this is where you're going to use that zero product property. So the first thing I want you to look at is this. Here are my three apparent factors. Let's go ahead and start by taking 3 and setting it equal to 0. That makes no sense because remember, you're trying to find the x-intercept and there's no x there. So you're actually not going to be using that particular apparent factor. But I am going to go ahead and use my x minus 3. And so when I set that equal to 0, I get x is equal to positive 3. And you might notice that both of these two factors are the same. So I'm not going to go ahead and do the work again because I'm going to have the same answer, which is 3. Now, I only have one number where the graph is going to cross the x-axis. If you remember, it looks something like this. This is called a double root. And you might be able to see now why it's called a double root. Take a look up here. Notice that two of my apparent factors are exactly the same. That's why it's called a double root. And you'll notice also in the answer, you only have one answer, 3, 0, because it's only going to cross that x-axis in one location. Okay, this is the first technique on how to factor a quadratic, or how to solve a quadratic. Let me teach you another method. I'm going to go ahead and scroll down, and let's talk about taking the square root of both sides. This is kind of an interesting technique. Now, if you take a look and just kind of glance at these three examples, you'll notice something that's unique about all three of these. We're missing the x term, or that b coefficient. We're missing it. In these examples, we only have the x squared and we only have the constants. In that situation, that's when you know you want to use the method of taking the square roots of both sides. So here's how it works. I'm going to start by moving the constants to one side and the variables on the other. So I'm going to go ahead and subtract 10 from both sides to get the constants together. And I'll be left with 16x squared is equal to 64. My goal is to solve for x. So let's go ahead and divide both sides by 16 to get the x squared by itself. So now I have x squared is equal to 4. Now, back when we learned about the Pythagorean theorem, we learned how to get rid of a square. And the way to do that is we square root. When we square root one side, we also have to square root the other. That eliminates the square on the left-hand side. On the right-hand side, we're going to be using both the positive and the negative root of square root of 4, which is plus or minus 2. So those are your answers to this quadratic. Where your graph crosses the x-intercept will be at positive 2 and negative 2. You could also break this down and write it as x equals 2, x equals negative 2. It essentially means exactly the same thing. Now, let's go ahead and write our answer in roster form. Roster form is squiggly brackets, and then I'm going to write plus, minus, 2, squiggly brackets. And I'm done. All right, I have two more examples here for you. Let's take a look at this next one. I want to get the constants together, so let's go ahead and start by adding 3 to both sides. That'll bring our constants together to give me 120. Okay, so at this point, again, you're trying to get rid of, you're trying to get the x squared by itself. So let's go ahead and divide both sides by 5. And that will give us x squared is equal to 24. I need to get the x by itself, so I got to get rid of that square root. So let's take the square root of both sides. Now over on the left side, that gives us x. But over on the right side, we have square root of 24, which we know is an unsimplified radical expression. So let's go ahead and simplify this down. I can break square root of 24. I can break him into 4, and I can break him into 6, which also breaks down into 2 root 6. So my answer here would be x equals positive or negative 2 root 6. So this answer is a little bit different than the one previously because this is going to give us a decimal answer or a simplified radical answer. This is one of those situations where when you have a coordinate plane, your graph is going to go between two integer coordinates. So that's just another situation of what this would look like. Roster form would look like this. Squiggly brackets. Whoops, didn't mean to write that little line here. Let me go ahead and erase that. Positive or negative 2 root 6. And you're finished. All right, the last example here that I want to show you is a little bit different. So let's go ahead and talk about this one. I'm going to go ahead and get the constants together. So let's go ahead and subtract 2 from both sides. And I'm left with 3x squared equals negative 12. I'm going to get rid of that 3 by dividing 3. And I have x squared is equal to negative 4. All right, you can see where this is going here. When I take the square root of both sides, I'm left with x equals the square root of negative 4, which we cannot take the square root of a negative number. This situation does not occur. This is not a real number answer. And therefore, the answer to this problem would be no solution. And the way that you could write it in roster form would be like this. A little circle with a slash through it. All right, that is the second technique on how to solve a quadratic. So we've talked about factoring. We've talked about taking the square root of both sides. And now what I want to do is show you how to solve in the graphing calculator. So I'm going to show you two different ways. I'm going to show you using Desmos, and I'm going to show you using the graphing calculator. Okay? So actually, I'm not going to do that. I'm going to do that in another video. So I'm going to go ahead and cancel this, and I'm going to pause the video, and I'm going to create a new video just on this.